Hello everybody, we are back and we are going to continue discussing energy metabolism, diet and weight control. So today I want to dedicate a little bit more time to that concept that we discussed before when we actually spoke about metabolizable energy. So I'm going to talk specifically about fiber, because if there is one thing that can interfere or affect how much energy is available in a particular food that you eat, is its content of fiber. And you remember when we discussed fiber, we were talking more about colon and production of short chain fatty acids, and also how fiber or fermentation of fiber could actually contribute a certain amount of energy to the organism. Even though fiber was not metabolized itself, you cannot break it down, but some of the bacteria living in the colon could actually ferment the fiber, and then they would produce the short chain fatty acids that could be metabolized by colonic cells, and that could actually provide some energy to our body, which we usually don't count, we don't think about. But let's go into more details here. So what happens when you eat foods that contain or have high amounts of fiber? What happens is that it reduces transit time of food. In other words, remember that concept of transit time is how long does it take for food to travel all the way from your mouth all the way to the back door, to the end, to the anal canal, where you can actually eliminate. So there is a time that it crosses this entire system, and we call it transit time. We could look at transit time also at specific areas of the gastrointestinal tract, but let's think of transit time as the time that it takes to travel, for foods to travel through the digestive system. So, and it results in because you have more fiber, you reduce the time. In other words, you shorten the time that food is within the system or inside of your gut to be digested and absorbed. So if you have more fiber, just to begin with, I think it's fair to assume, or it's fair to state, that because you accelerate the movement of food through the GI tract, you reduce also the ability or how much of that energy that is in that food will be absorbed and therefore used by cells and tissues. So it tends to reduce transit time and make it less available, or make food less available for absorption. So obviously that could, in theory, reduce metabolizable energy, or the energy that is available for the system. Fiber also increases the bulk and water holding capacity. In other words, it makes the bolus or the chyme. Remember when we spoke about chyme, and then you have that going into your from the stomach into the small intestine and then into the large intestine. So because it holds, it increases that you have less metabolizable elements in there, or components in that food because of the fiber. It also increases water holding capacity, so it kind of brings water with it. So it reduces the rate of diffusion of digestion products towards the intestinal mucosal surface for absorption. So you have not only a barrier because the fiber gets in the way, but you also make it increase the bulk of it. So you make it volume bigger, and then the diffusion from the core area of that particular material towards the surface of the surface of the intestine, or the mucosal surface, then it makes it more difficult for nutrients to be absorbed. So in that, it includes for carbohydrate, fat, and protein, which are the three major components, or three major macronutrients that actually provide energy to any organism. So dietary fiber may also cause mechanical erosion of the mucosal surface. Imagine if fiber is a rough material that is not digested, it can actually, when it passes by, as it moves along the GI tract, it can actually erode the surface, a little bit the surface of the GI tract. And for that, it leads to increased endogenous material that is excreted along with the contents of undigested and non-absorbed nutrients. So that also causes some loss of material that could represent, to some extent, energy in the system. And as I mentioned in the beginning, there is liberation of the energy content of fiber by fermentation. So you have bacteria living in the gut that actually will ferment the fiber, and that will provide those short-chain fatty acids, as I mentioned in the beginning, that can serve as fuel for colonic cells. So there is a certain amount of energy you lose, but there is also some energy that you gain given the fermentation of fiber, especially if it's soluble fiber, because insoluble fiber will not be fermented. That will probably erode the structure of the surface a little bit. It will increase the bulk of the feces and will drag along everything else. So all these things are mostly caused by insoluble fiber, because that cannot be fermented by bacteria at all. So there is some loss and there is some gain of energy. And again, when we eat foods, we look at the label. If you buy bread, or if you buy pasta, or if you buy fruit, you know how much carbohydrate you have there, how much fruit, how much protein, and how much fat you have in that particular food. And the label usually gives you the number of calories based on that content. But it's a different story when it actually goes through your GI tract, because there are a whole bunch of other things that happen that can affect how much energy will be available, and in other words, the metabolizable energy that your body will be able to use. So dietary fiber may cause mechanical erosion of the mucosal surface and lead to increased endogenous material, as we spoke before. If the total amount of metabolizable energy is not sufficient to sustain all metabolic processes, what do I mean by this? Let's say you eat a certain amount of food, and then because of this loss or relative loss of energy or gain of energy, so the net gain of energy, whatever is absorbed in terms of energy out of this whole thing, if this is not sufficient to sustain all your metabolic processes, or in other words, all the energy that your body requires to maintain its function, then what the body does is it will mobilize its fat stores. And usually it's your adipose tissue, where you have triglycerides, as abbreviated here as TGs, or triglycerides, which is located in the white adipose tissue, and also glycogen that is stored mainly in the liver and skeletal muscles. So let's unpack this a little bit, again, just to make it clear. So if the sum of all the metabolizable energy that you are getting in once you eat food in the end of a day, if that is not sufficient to take care or to fulfill all the energy needs that your body has, what happens is that your body now will have to mobilize some, or get some additional energy. It has to compensate that by taking energy from the adipose tissue. So it mobilizes the adipose tissue for fuel. And also remember, we have glycogen, which can also provide energy, and this is stored in skeletal muscles and liver. So what happens is that both will be mobilized. More so triglycerides, because your body always tries to spare glucose, because you have limited amount of it, limited supply of glucose. Remember this. We have a lot of fatty acids, we have a lot of fat, energy stored in the form of fat, but we have a relatively limited supply of glucose, which is in glycogen and in muscle and liver. So your body, as much as possible, tries to spare glucose and use more fatty acids. So again, it depends on how much energy is available ultimately. That's the concept of energy in and energy out, again, that we were discussing. So your body has the ability to mobilize additional stores in case the metabolizable energy that you're getting from the food is not sufficient to fulfill the energy requirements of the organism. So thus it is the amount of energy in and out, as I mentioned, that ultimately determines the size of the fat and glycogen compartments in your body. So if the metabolizable energy is sufficient to meet the energy demand of your body, you don't even touch your glycogen or your fat. And if it's more than what you need, you actually increase the stores of fat and glycogen. So there is a direct relationship between the size of these different compartments in terms of fat and glycogen, depending on, or directly relationship with how much metabolizable energy you get from the foods that you eat. So this kind of gives us an idea of how much energy you get in. So you have all this discussion so far was to kind of characterize the different components of this energy in aspect. And also we have to look now at the energy out, because it's not only depending, if you don't exercise, you don't do anything, then it's basically only the energy required to maintain your basic physiological functions. But if you do more activity, so you have an additional demand for energy. So there are different mechanisms that play this, or that interact all the time to determine how much energy is available and how much energy, or if a surplus or a deficit of energy is actually being established in the organism. So what we are going to discuss now is the determinants of energy expenditure, because we know now that energy in depends on the foods that you eat and also on the ability of your body to process the food and absorb energy. So that's the idea, what we spoke about, of metabolizable energy. But now the other side of the equation is energy out. So what are the determinants of energy expenditure in your body? So the other side of the equation now. So we have basically 4 different components here. Today I'm going to just basically present them, and then we are going to discuss in the next classes, we are going to discuss every one of them in detail and understand exactly what we mean by each of them. So we have, as I said, four basic determinants of energy expenditure. So basal metabolic rate, that we abbreviate as BMR, and some people call it resting metabolic rate. So it's normally used interchangeably, basal and resting. Some people would defend the idea that resting is a better way of saying, because it's very difficult to establish what basal is, because basal metabolic rate would be like the minimum amount of energy you need to maintain the basic functions of your body. And this is usually when you're in the resting conditions after an overnight fast. If you slept well, you're in a reclined position, but you're not sleeping. So you have to be awake, but in the most rested state possible. And so for that reason, some people say that it's very difficult to establish what is really basal. So they may also call it resting metabolic rate. So you can see both of these terms used interchangeably. They refer essentially to the same thing. And then we have another one that is called the thermic effect of food, that we abbreviate as TEF. Basically, it's the amount of heat that is produced when you eat. We're going to discuss exactly what it means. And it's also sometimes referred to as diet-induced thermogenesis, or DIT. And we are going to discuss this in detail, because diet-induced thermogenesis plays a very important role in how much energy is available or not after you eat some food. So again, it's the energy that is in, but also how the processing of a food that you're putting in your mouth or going through your gut, how much it affects actually the metabolism of your body. So there is also an energy component involved, an energy expenditure component involved in eating food. So we're going to discuss that, and we call it diet-induced thermogenesis. And it's a very important concept that we usually neglect. Then we have what's called adaptive thermogenesis. That is how much your body adapts to different environmental conditions, such as if it's a cold environment, you need to obviously maintain body temperature. So you have to accelerate or increase your production of heat, or thermogenesis. And for that reason, there is obviously an energy cost associated to that. And lastly, physical activity, which is the energy that you spend every time you move your body and every time that you do something that involves movement or physical effort. So it can be very little or it can be very high depending on how much exercise you actually do. And some people separate the physical activity, or there is a separation of physical activity and exercise. Physical activity is the idea that everything that every movement of your body is considered physical activity. It doesn't have to be planned. It doesn't have to be systematic. There is no specific set of rules for that. Anything that spends energy in movement would be physical activity. Now, exercise, some people consider it more of a structured program where you actually have a control of frequency, duration, intensity. So that when you prescribe the exercise for someone, it's more a structured way of doing this. So you actually say you're gonna, let's say you're gonna run 3 times a week, you're gonna do this for approximately 20 to 30 minutes, and you're gonna keep the intensity between 70 or 75% of your maximum heart rate. So that, there you go, you have all the different components that make up exercise prescription really established and well structured. So that's the difference between exercise and physical activity. So these are the 4 components that determine energy expenditure, and we are going to discuss in detail each of them and see how they affect whole body energy expenditure and how it relates to this idea of energy metabolism, diet, how it interacts with diet, and also how it affects weight control. So for today, we are stopping here. I'm going to try to keep these lectures relatively short, between 15-20 minutes. Let's see if I can do this, but we can discuss little by little all these different components of this chapter of this course. So thanks for watching, and we'll see you next time. Bye for now.